We're going to solve a law of sines problem where there are two possible triangles that can exist. One way to help you when you're going to end up drawing your second triangle is by drawing the first triangle with the given angle at the bottom left, and then the unknown side, which is side B because we don't have a lowercase b, at the bottom. Side A is 14, so that's across from angle A, and side C, lowercase c, is 16. Now we can solve for what we can, which is angle C. We can do the law of sines, sine of 30 over 14, that's the ratio we know, and then that equals sine of C over 16, because C is what we're trying to find. Then we can cross multiply. We want to get C by itself. We can't divide by 14 sine, because you always have to be taking the sine of something, but we can divide both sides by 14. So now we have all of that equals the sine of C, but we need to get C by itself. So to split apart the sine from the C, we have to inverse sine both sides. And now the inverse sine and sine cancel and we have C on the right side. When you plug all that into the calculator, inverse sine is second sine. Make sure your calculator is in degree mode, so go to mode degree. And then when the parenthesis comes up after the sine, make sure you close the parenthesis after 30. And you end up getting 34.85 degrees. So now, because we have an angle side-side triangle or side-side angle triangle, there's going to be two possible solutions because this angle is greater than the given angle. The first angle we found is greater than the given angle. And if you don't remember that, just try drawing the second triangle and see if it makes sense. So there's a few ways of drawing the second triangle now. One way is sliding the angle that you first found, so that'd be angle C, along the unknown side that's allowed to change length, so that would be side B, until angle C becomes obtuse. So we can slide it along that side until that angle is now going to be obtuse. Or if you always label your triangle with the given angle at the bottom left and then the unknown side at the bottom. When you have an angle side-side triangle, then your triangle will always look like this for your second case. And we can label everything that was given again. Now we can solve for angle C. We don't want to do the law of sines again because that's what we just did here. So if we do that in the calculator, we're going to end up with the same thing. We need to find the answer that the calculator didn't give us when we did inverse sine. We need to take 180 minus what we got from the calculator, 34.85. And that gives us 145.15 degrees. And if you didn't memorize that two triangles exist because 34.5 is greater than the given angle, you can look at the triangle and it makes sense that this triangle exists because the bigger angle is across from the bigger side and the smaller angle is across from the smaller side. And another way you could have drawn your triangle is just a normal triangle, not drawn to scale. And then at the end, just making sure you draw it so that angle C is obtuse. I know that's a lot of work and we're not even done yet because we still have to solve for the rest of the triangle, but that's the hardest part. So if you can understand that and keep practicing that, then you'll be able to get the rest of both triangles.